Hey, I was going to shoot a quick video for a friend, Dave, that's thinking about getting into 3D printing. So this is a quick shot of Fusion as I have it. Where you can make a free account and you're only able to, I think, have 9 editable documents or something like that open at once, which is fine for a home user, and it's nice that they make a free version. So these are some of the things I've drawn, and you can export these and take them out of Fusion. Just you can have as many items as you want. You can only manipulate a certain number of them at the same time. Anyhow, we'll grab something here and look at it. And this is web-based as well. It does a lot of its processing off of your PC. So you can see there's origins here that you can draw things on. This is it's designed to clip onto a pneumatic cylinder with a magnetic piston. This little notch holds a standard reed switch. That opening is designed to be an interference fit for a 9-volt battery. And this little boss I've made is an interference fit for an LED. But when you look at a Fusion360 file like this, you can, it'll show the steps, that I took to draw this. So if I click on one, you can see apparently I started with a circle. It's been a while since I did this. Just drawing on the horizontal plane. So it looks like I specified a distance between center points at 2 circles and joined them like that. And then other drawings, it looks like I rounded off the corners, made the little spot for the 9-volt battery. Looks like I drew the notch there. And I lofted it to the thickness of the item. Anyway, you can see each step where I drew that boss. I radiused it, made the hole in the middle, blah, 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 cut chamfered edges. Anyway, you get the idea. So you can either get something off Thingiverse, or you can use one of these programs to, there's a little orientation thing there, so I can rotate it around and look at my object. So once you've got something drawn you think you want to print, you go up here to File and Export to get it onto the local computer here. And it's going to come up default as a Fusion360 file. It retains all the dimensions and drawings and whatnot that you see here, but for 3D printing we're going to want to make it an STL file. It shows what the target is. I'm just going to call that sensor clip 28mm. Delete some of the superfluous stuff there. So it'll take it a minute to fling it onto the internet, process it, and fling it back here. Hopefully not too long. Okay, so that's saved onto my computer, onto a folder where I keep 3D printable stuff, so I can, get something off of Thingiverse or some of the other file sharing things. Once I open that up, I'm using Ultramaker Cura as my slicer program, and I've got it set up for my particular printer. So you can see there's my object right there, and you can on this program right click and move it around, look at it, whatever. Up here it is, you can customize profiles for the material you're using. This particular one is super quality PETG with a 0.12 layer height, kind of like resolution when you're printing. That's high resolution. Also, PETG is a hard plastic, and the way this is designed, I want a flexible plastic, and you can see I've made a couple profiles for the GPU plastic that I like to use. One with 40% infill, one with 20% infill. I don't really know which one I like to do this in, but we'll select that profile. And if I wanted to, I could edit the layer height, or I can edit the wall thickness or infill or any of that. Wall thickness and top and bottom height are the thickness of solid plastic before it starts doing the infill. It'll show the infill pattern. Cubic works well. Just kind of stuff like that you figure out. Here's my printing temperatures. So the nozzle is at 215 Celsius and the print bed is 100. Flow rates, it'll be a little higher on the wall to make sure that that's bonded well. For most of this stuff, all the defaults will work fine once you figure out the temperature of your material. Once you're happy with that, you can hit slice. So it now made it into a file that the printer can operate on. Gives me an estimate that it takes 4 hours to print this and 41 minutes. I found these to be a little high. It'll print it faster. Claims it'll use 14 grams of material. So I want to make sure that I have more than that on the disk. So I can save it to a disk and export it to a micro SD card. Or you can, if you hit preview, now it's showing the object here in kind of a progress bar. So I can drag that down and it will show. You can see the infill that I have there, but it'll show the pattern that the printer is going to do. It also shows, in this case, I've added a brim around it, which helps it stick to the bed. It'll basically do a one layer, however wide you set it for, area to stick to the bed, and that'll generally peel off on its own. If it had an area of overhang, I could set it for supports, and it would make a piece of plastic not well bonded to the part, but just to support it where it's going to bridge over an open gap. Anyway, if I'm happy with that, I can hit save to disk. Could open something else, I suppose. Might be a better example. Let's see. Well, this is a gas cap that I made for Tom to replace the cap that was missing on his jerry can. So you can see it's hollow underneath here, and it has kind of a radius here, which is where it when you screw it with the nozzle down, that's the area that seals to the cap. But if I were to slice it with supports, let's see, I'll switch to, that would be something we would want to do. Super quality PETG. Hit preview. So now if you look at this, you can see where it's printed this support underneath, and that'll be really lightly attached. You'll be able to break that off with your fingers, but its whole purpose is letting the printer bridge across the top here. These little white spots are where it's going to layer hop. I think they're set on random or sharpest corner. Otherwise it might line them all up in one spot and make kind of an unsightly scar. So if I'm happy with that in super high resolution PETG, I could save it. And again, this PETG is a hard plastic and it's pretty chemical resistant. It'd be good for this little gas cap. So just for giggles, this is back in Autodesk 360, and what I've done is I've opened this object, the STL file that is for this object, just to kind of show that's what STL is. It's using these triangles to define this, just the outline, the shape of the object. No texture or dimensions or anything. It's just defining these curves and every part of it with triangles. So that makes it kind of difficult in Fusion 360 to edit something like this, because you can't really grab a particular plane that, you know, if I wanted to draw something here, make a circle and project that into a hole or something, it's sort of difficult with all these intersecting lines. But anyway, that's an idea of the shape that the slicer program wants to look at. And then that's just an example of that cap looking at the G-code as a text file. And the commands that it gives the printer that it needs to read. A person can insert special processes like a pause, change colors in the middle of something, or temperature change at a certain layer height. So that's that gas cap, you know, is the type that goes on the end of the spout, and when you turn the spout around and into the can, it goes on top of the back of the spout, and then the screw ring locks it onto the can. For a Blitz can, and the company had gone out of business, so that's why I ended up drawing these. There's kind of another version of it. I actually put embossed Tom's gas cap across this one just for giggles. It's one of the things you can do with Fusion 360 is wrap text around a curved surface like that. Okay, pardon the mess in the shop, but here's my printer. I keep a dust cover over it usually. It's an Ender 3 V2. The V2 just has a 32-bit processor over the previous 8-bit, and the drivers that run the motors are quieter, but otherwise I guess it's pretty similar. Been around for a long time. Has a little tool tray where you can keep extra nozzles and picks to remove a clog, and control panel here with a push and rotate knob, slot for an SD card. Its power supply is back here along with the power switch. So you can see it is a Bowden tube printer. I did put a new Bowden tube into it once. If you're running high temperatures, you might distort the end of it or whatever just over time. Or these little couplers can wear out, and if the tube can pull in and out of the coupler, well, that interferes with the extruder trying to push and pull the filament. But for me, it does what I need it to do. It won't run real high temperature filament, but it's also inexpensive and easy to use. So if I haven't used this in a while, I'll take some isopropyl alcohol and I'll clean off the bed, and the scraper makes sense. Then a person would power it up. It does have a noisy fan. I think it's actually in the power supply, but it usually calms down. Detected unexpected stoppage. Cancel that. So here we have it booted up, and so it's sitting here. So if I wanted to print something, first thing I would do is go over here to prepare, and it shows the nozzle temperature, and its target, so 25 Celsius, and the bed is showing 27 Celsius, and the targets are 0 on both because it's not trying to heat anything. If I go to preheat PLA, it's going to try to push the nozzle up to 200 and the bed up to 60 Celsius, which is fine. I could go over to the control section there and set the bed to a different temperature if I wanted. Once the bed comes up to temperature, this model has manual leveling, so it uses these little knobs on each of the 4 corners to level the bed relative to the nozzle movement, and that needs to be pretty precise. That first layer, it needs to stick to the bed or your item will fall over. If the nozzle is too close, it won't be able to extrude plastic and it will clog. Or if you have like an embossed surface on the bottom side of something, it'll obliterate that. So anyway, if I was getting ready to print it, I'd let the bed temperature come up and give it a minute to stabilize. As you know, this bed will warp under temperature, and once it's got the temperature stabilized, we'd go over here to Auto Home and select that. Please don't other operations. So it is a machine from China, so it has not the best grammar. So that's going to drive the print nozzle to a specified point on the corner of the bed. And there it is, and it's going to lock. Now, one with auto level can go around the bed with a little probe and kind of measure the bed height and adjust by itself, but this one, as I said, does not. So now the stepper motors have everything locked right in that position. And what I want to do is go over here and hit disable steppers. And what that allows me to do is move the print head kind of even with this adjusting knob. And now I can bring the bed back, and I'm doing this without disturbing the Z-axis. And that's already hot. So I want the nozzle about over that knob, kind of isolating each adjustment so it doesn't teeter-totter around. And for most filaments, just a lightweight piece of printer paper, and moving that knob. I have a bad habit of going the wrong way until I figure my stuff out. There, that's tight. That's a little light. And I can just kind of feel a little bit of vibration. You can almost hear it as that paper drags under the nozzle. So I've got my height set there, and from there I'll move the bed here until I'm above that back knob. Slip my paper under there, set the height for this position, and I'll repeat that for all 4 positions until I've, as the nozzle travels, it'll be an equal height above the bed. Once that's done, I can go up here to move, and I can command the extruder. Oops, wrong way. Oh, I don't want to move the extruder. What am I doing? Sorry, we'll bring that back to 0. I do have command over the extruder. I see we're going to go to Z-axis here. And instead of 0, where it's just homed, I'm going to bring it up a ways. And so now I'd get out my filament. If I was going to use PETG, I've got some here in a couple different colors. I've got lots of PLA. There's TPU as a flexible filament right there. So if I was going to do that sensor clip, I'd put my filament here. We'll run the filament through this knob here into the extruder. This little manual wheel will let you turn it You may have to disable the steppers. But I've got this nozzle up so I can run the filament through here and push it through that hot nozzle until I get a pretty good stream of it coming out, just to purge any of the last color that might have been stuck in there or whatever. And pushing it out with that dial faster than it normally would will kind of knock out any sort of debris. And then once I had it ready, then you'd be ready to start a print. So these filaments, I think we mentioned earlier, can pick up moisture out of the air. In our environment, I've found it keeps a long time just in a freezer bag, and I'll put a packet of desiccant in there. And then when I'm printing, some area where the printer isn't going to be, I'll set the desiccant on the print bed for a few minutes to dry it back out and put it back in the bag. Obviously, while I'm there, I don't want it to over dry and catch fire. But if you leave like this little cheap sample of PLA that I got, and I just had a little bit left, I didn't bother putting it in a bag, it's become brittle. So it might actually snap as you're trying to load it. And also it won't print that well when it's just been out in the open air. So for somebody starting out here, it's not really worth it, but I do have a commercial filament dryer. And if I set that on default for like 6 hours, it would cure a lot of that brittleness. So anyway, once I had it loaded with filament, I can go back here, go over here to print, and there's my gas cap, or a mirror or whatever, hit it, and it will go ahead and start printing. If I did that right now, it wouldn't activate because the filament sensor is empty. So some filaments kind of like the room to be warm, but most of it will print just fine in a normal, comfortable temperature room. So let's see, what else can we show? Oh, here's that, this machine sizes and injects lubricant into a traditional cast bullet. Like this is a cowboy bullet, basically, that'd be used in like a 45 Colt from the 1870s, 1880s, that kind of thing. So there's a reservoir here that takes sticks of that wax-based lube in there, and I've got this air cylinder that pressurizes the lube when this thing is operating. Works better than a hand crank because it maintains an even level of pressure. The bummer is, it has an air piston in there. You have no way to see when you're about to run out of lube until you start ending up with bullets with no lube in them. So that's why I printed that thing we were looking at here. This is flexible filament, so it'll snap over this air cylinder. Got that reed switch, the LED, and the 9-volt that fits in it. And if we slide it up here, that's where my air piston is right now in this cylinder. That's where it trips the reed switch. So I've marked this air cylinder with a Sharpie there. If I leave it like that, when that LED goes off, I know I've used enough lubricant that I can fit in a new stick, but I'm short of running out. So, that's just kind of an example of something a person can custom design on a 3D printer that would be hard to make otherwise. Another thing, different project. This is threaded on one side for a universal cylinder, whatever that is, 20 millimeter or something, and then goes up to like 30 millimeter here. And those threads are 3D printed. Like there's no way I'm going to buy a 30 millimeter tap for whatever little project I did, but I can, in high quality PETG, I can print usable threads for stuff like that. Other little things. Oh, I had some filament ends to use up, and so I went on Fusion360 and I drew a 45 Colt case, made some inert trainers if you wanted to demonstrate to somebody you know, a lever action or the proper handling of a single action army or whatever. You got these little, obviously inert trainers. That's a same thing. I just kind of measured out and drew a 357 Magnum case. Here's some rear view mirrors I made for ATVs, where you just put the little stick-on blind spot mirror on there and use a ram mount. And the handlebar end that would normally retain the grips onto the end of the handlebar have like an M10 thread on them. I just drew this so that, you know, part retains the grip, has that same shape. It's got a metal bolt through it, and then I've got my ball here for a ram mount clamp for my mirror. That ended up working really well. One thing about 3D printing, the layers will snap fairly easily. So for this, you know, I needed a metal screw anyway for strength, obviously, with the load on it. So I printed M10 threads. Are kind of small for that thing to print and make them usable, but if you print them and then you can run a tap, you're never going to find in the States anyway an M10 long shank tap that would go all the way through this. So by printing threads in it, I can get the tap from one way and tap from the other, and the 3D printed threads make it easier to cut, but also get the you'll let you cut the threads from both ways and have them be in time, you know, that they're synced up. And then some Gorilla Glue, when you screw that bolt in there, bonds to the plastic all the way, and that otherwise it would tend to fracture between layers there when something hit the mirror and tried to torque that ball off. But anyway, just stupid little things I've designed with that thing. And yeah, I can't think of anything else to really add, but I wouldn't hesitate to try one. It doesn't have to be an expensive one.